Hi everyone, myself Arko Jyotide, and in this video, we are going to solve question number 3402, that is minimum operations to make column strictly increasing. So, first of all, before jumping into the question, we should understand that what is strictly increasing. Strictly increasing means suppose we are given an array 1, 2, 3, 4, 5. Okay, so I need to make some space. Okay, so 1, 2, 3, 4, 5. It is in increasing order, right? But we can say it as strictly increasing because there are no two elements equal. If we are talking about something as strictly increasing, the graph will always go up high. There will be no such case that two elements will be equal. Like there cannot be two and here cannot be another two. This is also in sorted increasing order, but we will not say it as strictly increasing because here the graph will be like it goes up like this and then it will be constant and then it will go up. So strictly increasing means your current element should be at least one greater than the previous element. So what we are given, you are given an m cross n matrix grid consist of non-negative integers. So we should uh, like highlight the point that we are given non-negative integers. That is, our integer will be from 0 to the maximum integer value. In one operation, you can increment the value of any element by 1. So incrementing the value of an element by 1 will be considered as one operation, and you should be returning the minimum number of operation needed to make all the columns of grid strictly increasing. So we are given this array, this 2D matrix 3 2 1 3 3 4 0 1. First of all, focus on one column of the matrix only. We will iterate a loop and we will check for every other column later on. So what is given in this thing? So if I will make it, I will uh, open a drawing board. um, Paint. If I will open a paint, then the brush size, that's okay. So what I've got this. Hmm. This is, I think this will be okay. What is the question? 3130, right? So 3 1 3. Okay. So when we will iterate, when we will we are checking this element, that is the row index 1 and column index 0. When you're checking this element, is it strictly increasing? Is it is greater than 3? No, it is not. So what we can check that the previous element is 3, right? So 3 minus 1. So what number we should add to 1 to make it strictly increasing than 3, to make it bigger than 3? What is the minimum number that we should add? Because we should return the minimum number of operations, right? So the minimum number you can add to 1 to make it greater than 3 is 2 3, right? You can add 3. And how this 3 is coming, how we are getting the answer as 3, we can say that we should add something to the element of this index to make it greater than the previous index, something as this minus 1. So if we add this to this index, then it will be equal, and to make it 1 greater we should again add 1. So this thing we should add. So what formula we are arriving at, right? So what is the formula we are arriving at? I think I need to erase something, right? Okay, so our formula will be, we what we are adding to make it equal, we are adding the previous minus the current, right? This thing we are adding to make it equal, and to make it 1 greater we should add 1. So this thing we should add on each and every element to make it uh, greater. And suppose like it is right, it would take time to actually, so we can, so suppose we are not given an array like this, suppose we are given an array like suppose we are given an array 2 1 uh, 3 3 4. So here we will add 2 minus 1, that is 1, plus 1 2. So when we add 2 to 1 we will get 3. And now, okay, let's make this as 4. If we will make this as 4, our intuition would work fine. Let's make it 4, right? So what we should add to this element to make it greater than this? Oh, it is already the current element. If we focus on this, the current element is already greater than its previous element. So do we need to add something? No, we don't need to add something. So if the current element is already greater, we don't need to add anything, because we should return the minimum number of operations. So what our code will be, we will be traversing the whole column, and we will check if our current element is greater than the previous element or not. If it is greater than, then it's fine, we don't need to perform any kind of operation. And if it's not, then we need to like increment, and how many times we are incrementing, that will be our number of operations, and we should add till how many times of operations we are doing, right? So what our time complexity and space complexity will be. So we are not using any space, and it is a good practice to not change the input array that you have been given. You can use a previous variable to store what changes are we going to make. It's like the tabularization method of dynamic programming, right? In memoization you are changing it, but in tabularization you are using 2 to 3 variables to, you know, to store what we will be using in this step. So we will be storing what we should change. We will be not making the changes in the input array already, right? So if I will show you the code, then you can see, like first of all I have declared a variable total operations, like dot ops, right? It will be storing how many total number of operations uh, we are going to perform on this whole matrix, each minimum number of operations. M is the grid length, right? m columns. We are given m columns, so I am storing it in m. As here it also m cross n, here it also the naming m and n is used. So for like removing any clash or like removing any confusion, I am using the same m and n. Grid of zero dot length, like this will be give me the number of columns that I have. I have n columns, so I will store it in n. And here I need to iterate over the columns, because first of all, if I will be like first of all I'll be given something like this, right? If no, that should not be the case. Okay, I'll be given something like this, right? And first of all I need to iterate over the whole array column wise. Then I need to iterate the whole array of this column, every element of this column. So here I am not going row wise, I am going column wise. So I will be the first, my the first loop will be iterating over column, that is equals to 0 to n. Then I am using this uh, previous variable. I'm storing it -1 because for the first time, like here it is 3, right? For the first time it will have a number between, as the numbers are already given in the constraints, as the numbers are between 0 to 2500. So I won't have anything lesser than 0. So if I take -1 and the numbers here starts from 0, then my condition will check that okay, it is already greater than -1. So I don't need to perform any operations. And via like by using common sense, you can already see that for the first element you for the first element of every column you don't need to perform any operations. But that's why I have like assigned previous to -1. You can also do one thing, if you don't want to like take this kind of hassle, you can make it 1. So for that way it should run, right? If I make it 1, hmm, no, it is not running. Why is it so? If I make it 1, okay, okay, okay. If I'm making it 1, so I should assign previous as the first element of every row, that is grid of uh, the column will be, the row will be, row number will be 0 and the column will be C. And now this should work fine, I guess. And yeah, it works. If I submit, the code will get submitted. So you can also think it like that way, that I am using I am assigning previous to -1 for the first element, something that will be always lesser than the first element, or else I can like start from the second element of every column, but I should assign the first one as the previous. So next I am assigning current to the current element. Like I'm using this current variable because every time you don't need to write grid uh, like bracket of r bracket of c. Every time writing this is like a tiresome game, right? So that's why I'm not writing it every time. And what I'm doing is previous is greater than current, and this is false. It might be a little bit confusing. Like here you can also write if previous current is greater than previous, and if this is false, then this condition should run, else previous will be my current element. For the next iteration I am assigning previous to current. Here you can also give uh, if previous current is greater than previous, right? Current is lesser than equals to previous, and you can remove this thing and it should work equal. Yeah, it works. So I'm again declaring and in like declaring a variable of numops. It will uh, store how many number of operations that I need to do for this current element, for the element that I am currently pointing to. So that will be previous minus current plus 1, as I have already shown you. And total operations, uh, I am using a variable as total operations to count the number of like total operations that I need to return to the main function that this like the question wants me to calculate. So I'm using a total ops variable, and my previous will be current plus numops. So I am not changing my input array here. I am storing it to previous as current plus numops. So this is the number of operations, means one operation is equals to one increment. That's why. And then I'm returning this total operations. So if I will submit this code, mm, it gets submitted. Memory is a bit high. So can I? Oh, sorry, enough. There is not enough data. So can we check some other solution so that we can? Oh, we haven't really discussed the time and space complexity, right? So if I talk about the space complexity, we are not using some extra space or like stuff like that. So this will be big of one. And for the time complexity, you can see that we are traversing on each and every element of the array. So the time complexity is big of number of row into number of columns. That is here big of n into m. Hmm. If I will check this code. Okay. Time complexity big of mn. This is one. Iterate gridwise. Last one is give to the last. Perform grid plus grid of last plus one minus. So add this to answer. Okay. Same thing, right? Plus plus or yeah, same code I guess. We haven't used too much of variable. Used something like okay. We have actually in this code the input array is actually changed. So if you are changing the input array, I will say that you should talk to you should tell to your interviewer that I am changing my input array. Is it okay or not? I think there won't be. Okay, let's check Python code. Python code is same as well, so no problem. Okay, so this question is solved and it's a pretty easy question and it is a easy level question. So done.